These are the solutions for the study guide for the 21st test for algebra. So let's take a look at our first problem here. So what it says is that we're supposed to solve the equation by completing the square. So we're going to follow the directions that they say. So there's a few different methods we can use. Completing the square is one of them, and it actually works pretty well with this problem, because this is one in which we go ahead and when we solve, we wouldn't be able to factor it. And it's easy enough to complete the square because we don't have the a term. So the first step you're going to want to do is get the c term to the other side. So again, when I'm mentioning a's, c's, I haven't mentioned b yet, but if I did, it goes in this form: ax squared plus bx plus c equals 0. That's the standard form. So when I'm talking about a, it's the number out in front of x squared, b is the number out in front of x, c is the constant. So from this stage, what I end up doing is I take half the b term. So I take that 8 and I divide it by 2, and that makes 4. And then, because that's what the two numbers that need to add to make 8x. See, when we're trying to complete the square, we want two binomials that are the same. 4x and 4x make 8x. Well, from there, your last term is 4 in each of the binomials. So when you multiply the last terms to come up with the trinomial, you have to square the 4, or it's 4 times 4, which makes 16. So that's the number that you end up having to add to both sides. So from there, I go ahead and factor. So this trinomial is a perfect square trinomial. It factors down to x plus 4 quantity squared. It always happens to be whatever half the b term is, always ends up going inside the parentheses. Over here, I combine these two terms, negative 13 and 16, and that's where I'm getting 3 from. So from this stage, I go ahead and take the square root of both sides. That's going to cancel out the squared symbol here, and I'm left just with the x plus 4. Now on this side, I can't take the square root of 3, so I write plus or minus the square root of 3. So I got one more step at least to write the exact answer, and the exact answer would be this: negative 4 plus or minus the square root of 3. But they want us to round to the nearest tenth when necessary, and this is a good time to do that. So I go ahead and take the square root, so I'll go ahead and take the square root of 3, so I'm going to just enter in there negative 4, and then I have plus the square root of 3, and that gives me negative 4 plus the square root of 3. Press the SD button, and that gives me negative 2.26. So you can see how I'm going to round to negative 2.3, because that 6 is just big enough there to round that up to a 3. So negative 2.3, and then for the next one, I'll clear that, and we'll plug in negative 4, and we'll this time do minus the square root of 3. And it shows me what it is in the exact form, and so all I'm going to press is the SD button here, and that gives me negative 5.7. So again, the 3 in the hundredths place is not big enough to round that up, so we'll just write the answer as negative 5 and 7/10. And so there's my roster of solutions, and we've got it. So let's go ahead and move on to the next problem. Very similar. The difference is now we have an odd b term, so that's what's going to be a little bit tougher here. So it's still asking me to solve by completing the square. So I have x squared plus 3x, and then leave some space because you got to add a number here, equals 4. So what number do we have to add? Well, let's go ahead and take half the b term. So half of 3 is, now don't write 1.5, leave it in the fraction form. It's really easy this way. You can do it without having to use a calculator. So 3 halves, and then I have to square that. So when you square 3 halves, it's just squaring 3 and squaring 2, so it makes 9/4. And that's the number I get to add to both sides. So what makes this a little bit tougher is that we just need to be able to add some fractions. So I'm going to go ahead and add the 4 over 1 plus the 9 over 4. So I'm multiplying this by 4/4, which makes 16/4. And when I add that to 9/4, that gives me 25/4. So that's the number I end up coming up with when I add the 4 and 9/4 together. So let's go ahead and rewrite what we've got. We've got the factored form here of x plus 3 halves. So whatever you get for half your b term always goes inside the parentheses, because those are the two numbers that add to make 3, multiply to make 9/4. And so this all equals 25/4. So I'm ready to take the square root now of both sides. And when I do that, I've got a perfect square. So I've got on the left-hand side the x plus 3/2. On this side I get plus or minus. Well, the square root of 25 is 5. The square root of 4 is 2. And you know you're doing something right if, when you do this, your denominators are the same. And that's what I have in this case. So I won't have to come up with that common denominator anymore. So I'm taking 3/2 away from both sides. So I'm setting up these two problems. 5 minus 3. And so the 5 minus 3, then dividing it by 2, so that makes 2 over 2, which makes 1. And the next one is negative 5 take away 3, which makes negative 8 over 2, which makes negative 4. So those are the two solutions to our quadratic. So the next one is going to, again, ask us to complete the square, but this time not solve. We're trying to find the vertex. And so the vertex formula for a quadratic is this. So if I have y equals x plus, or actually I'm going to write minus this time, x minus h squared, and then plus k. So the h and the k are just constants. They're just numbers that are being added or subtracted from the x and the one that's by itself. So the vertex will always be the opposite sign of what this is. And so it's going to be h in this case, and the same sign of what this one is, k. So that would be the vertex. If the problem was this, y equals x plus h quantity squared, and then I'll keep it as plus k, it would end up being, the vertex would end up being negative h comma k. So whatever the term is inside the parentheses, the answer, or the vertex, is always the opposite sign. This one here is always the same sign. So first step is to, let's move this 1 over with the y, so we'll just leave it over there just to kind of get it out of its way, get out of the way of this part right here where I want to complete the square. So just as we had done before, we half the b term and then square that answer. So half of 4 is 2, 2 squared is 4, so I'm adding 4 to both sides. And I get this by doing this rule right here. And so from there I can go ahead and factor this. So when I factor, got an x plus 2 quantity squared, whatever half the b term is. On this side, I've got y plus 3. So all I have to do is just move this 3 over, back over to the other side. So I have y equals x plus 2 quantity squared, and then minus 3. And so the vertex is negative 2 comma negative 3. See, x plus 2, so it's always opposite sign. This one's always the same. So over 2 spaces to the left, and then down 3 spaces. And then I just use the parent graph. It's a y equals x squared, so it's over 1 up 1. When you square 1, you get 1. You square 2, in the x direction over 2, up 4, because you get 4 when you square 2. And, oops, this point is going to end up being over 1 up 1 and over 2 up 4. And so that's what it looks like. Now, I can check a few things to see if I'm doing things right. First of all, it should cross the y-axis at the constant that we have right here, positive 1. This is the y-intercept. And so it's the y-intercept because when you set x equal to 0, you get 0 here. So just y equals 1. And that's what I have right here. So I know I'm doing that part right. So let's take a look at the next problem you see. Here it's going to be finding an area of a square. And actually in this case we're just trying to find the x value that makes the area 330 square inches. So first step is to remember that the area formula for a square is length times width equals the area. Well, here is my length or width, whichever one you want to call it, and here's the other one. So I've got x plus 2. I'll call that the length, and then the width I'll call x, equals the area of 330. That's what tells us the area is of the painting. And so from there, I'm going to go ahead and distribute. So I got x squared plus 2x equals 330. So it's kind of set up for completing the square. A nice problem because we've got an even b term, makes the problem easier. So we need to take half of the b term, which is 1, and then square it, and that's what I have to add to both sides, so positive 1. So now I can go ahead and factor this to x plus 1 quantity squared equals 331. So now I'm ready to take the square root of both sides, and I've got this, the x plus 1 equals plus or minus the square root of 331, Well, just take away 1 from both sides and you've got your answer. X equals -1 plus or minus the square root of 331. So now I'm ready to figure out what number it's going to be. Now, remember, you're going to end up with two numbers. One's going to be negative. So your answer, you've got a negative answer and a positive answer. And we don't want the negative answer. This is going to be an extra answer, or an extraneous solution. So that just means an extra answer that doesn't make sense with the problem, because we can't have negative length. Can't have negative length. And so we're just going to take the positive answer. This is the one we want. And so we can get rid of this negative answer right there and just use the positive answer. And so go ahead and get rid of that, what I did there. But you see how you have a plus and minus sign? We're not going to use the negative sign. So all I'm going to do is this one, -1 plus the square root of 331. That minus square root of 331 would give me a negative answer. So I'm going to go ahead and plug those numbers in. And so I'll plug in -1 and then plus the square root of 331. And that gives me an answer of 17.19. Now I think I needed to round to the nearest tenth. So let me check there. Yes, it says to the nearest tenth here. So I'm going to round that. So we're going to write that as 17.2 because the 9 is big enough to round that up. So we'll write the answer as 17 2/10 inches. And that's what the value of x is. So in the next one it says you are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border. Okay, so 3 square plots. So here's 1 square plot, and here's another square plot, and 1 more square plot. And then it says that the border is being surrounded. There's a 1-foot border around the whole thing, so it looks kind of like this. And so the distance around is 1 foot between the plots. And so this is 1 foot right there, and this dimension here is 1 foot right there. And then these squares have x units in both directions because they are square plots. They're all the same. So this side length is 3x because there's an x plus x plus x plus 2. And the way I got 2 is because there's 1 foot here and there's 1 foot over here. So that makes 3 x's plus 2 for 1 foot and 2 foot. Okay, so now this distance is 1x. See how you've got 1x going up and down, and then plus 2. It's plus 2 because you've got 1 foot here and 1 foot on this side. And so it says that we want to find the side length x of each square plot rounded to the nearest tenth. So we're going to have 3x plus 2 multiplied by x plus 2, and that all equals 100 square feet, because it says the total area of the garden and the border is going to be 100 square feet. So we use FOIL here, so we've got to multiply this out. 3x squared plus 6x and 2x makes 8x. And then 2 times 2 makes positive 4, equals 100. So this is kind of a nasty completing the square problem. So this is better for quadratic formula. It doesn't mention the method I should use, so I'm going to go ahead and use that. So I've got 3x squared plus 8x minus 96 equals 0. So I go ahead and plug in the numbers. Remember, the formula goes this way. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so again, your a term is 3, b is 8, c is negative 96. So I've got the opposite of b, and then a b squared, so it's going to be 8 squared minus 4 times a, which is 3, and c, which is negative 96. And this is all over 2 times by 3. So I go ahead and do a little bit of work there. Negative 8 plus or minus the square root of 64, and then plus. Now I'm going to go ahead and multiply some numbers there. So I've got 12 times by 96, and that gives me 1,152. And so when I go ahead and add these two together, plus 64, that gives me 1,216. So I can't forget about the division sign here of 6. So negative 8 plus or minus the square root of 1216. Again, I have the same sort of thing. It's all over 6. I'm not going to have a negative number. I don't want the negative number. I just want the positive. So all I'm going to look at is this one. Negative 8 plus the square root of 1216 all over 6. I'm going to ignore the negative answer because I know that's not the right solution. It's just the positive. So when I go ahead and plug in the numbers into the calculator, I'm going to use the fraction button this time. And I'm going to enter in negative 8 and then plus the square root of 1216. Now I've got to press the arrow button going to the right just to get the cursor to move over one space, so I'm out of the radical sign, and then down, and then I can start entering the denominator of 6. And so I go ahead and press equals, and it'll give me the exact answer. What it does is it simplified the radical. It just meant there was a perfect square inside the radical. And I'm going to press SD for the decimal approximation. There it is. 4.47. So let's see what they wanted. They wanted us to round to the nearest tenths place. So 7 is big enough to round that up, so it's going to be 4.5 is what I'm going to end up using. So I'm going to say it's about, x is about 4 5/10, and we are in feet. So that was that answer. Let's take a look at the next one. We've got some exponent rules here. And the first one is to multiply exponents. And so 3 to the second power, d to the second power, e to the negative 6. So you multiply there, times by 4 to the negative second, d to the 6th, and an e to the negative 8th. So my next rule is I'm going to bring the numbers next to each other, not multiplying anything out. Can't combine them because they have different bases. I do that so I can combine the ones that do have the same bases. The d's have the same bases, and e's have the same bases. And so I'm adding exponents here. That's the rule of multiplication. So if they're opposite sign, I subtract. That's what I have here. So I've got at least actually no opposite signs, all the same sign. So I've got adding here. So d to the 8th, e to the negative 14th. And so from this point, I'm going to take the reciprocal of any negative exponents. So I'll keep 3 to the second on top. D to the 8th stays on top. What goes on the bottom is the 4 to the negative second goes on the bottom to become 4 to the second, and e to the 14th. So I'll write this out as 9d to the 8th all over 16e to the 14th power. So looking at the last set of problems here, it's more exponent rules. So the key is look for the common factor. 2 goes into these, so I can divide this by 2, I can divide this by 2. So that makes 18 over 5. And then any negative exponents, I'm going to move those to the top. So I've got 18, g to the 3rd, g to the 4th, and then h so far. Down below I've got a 5 and just an h to the 4th. So my rule now is to subtract exponents. Well, I've got one h on top that's going to cancel out one h on the bottom, so that's going to leave me with the 18 still on top, g to the 7th, because I went ahead and added those exponents together, over 5h to the 3rd power. So 3rd power because there's 4 minus 1 makes 3. So the next problem, we've got to use the exponent rule, which says multiply exponents, 4 to the negative second, 5 to the negative second. And then I'm going to simplify some stuff down in here. So c to the 4th still. Here I've got c to the 6th power, d to the 3rd. And it's still all to the 5th. So I'm going to reduce a little bit here. So 4 to the negative second, 5 to the negative second. And I've only got one left on top. C to the 2nd, d to the 3rd, because these 4 c's cancel out 4 of the c's down below, so no c's left on top. Everything's still brought to the 5th power. I'm going to take some reciprocals here at this stage, and I've got 5 now to the positive 2nd over 4 to the 2nd. And on this one, I go ahead and multiply the exponents. I've got c to the 10th, d to the 15th. And I can go ahead and multiply out now. So 25 on top, 16 on the bottom, c to the 10th, d to the 15th power. And that is a 25 there, not a 2 to the 5th power. So looking at our last problem here, we are trying to solve a system, and it says Ed spends 1 hour on a boating tour, 2 hours on a walking tour. So I'm going to say B stands for the cost per hour for boating, and we'll say W is the cost per hour for the walking tour. And I'll set it up this way. 1B plus 2W equals 15. And the next one, Al is spending on a boating tour 1.5 hours. 1.5B, and then plus 6W, he's spent 28.50. So I'm going to go ahead and change this top equation here. I'm going to multiply it by -3. And so I'm left with a -3W, or -3B to start off with, minus 6W equals -30. So when I add this together, I end up getting -1.5B equals, well, -1.5. So it looks like the boating tour only costs $1. Wow, what a deal. And so B equals 1. And if I substitute that back in for this B, so I have 1 plus 2W equals 15. Subtracting the 1 from both sides leaves me with 2W equals 14. So it looks like walking's a whole lot more expensive. So $7 for the walking tour. So we now want to solve something. It says how much would 2 hours of boating, and 3 hours of walking cost? Well, 2 times 1 plus 3 times 7 would give us the answer. So 2 plus 21 gives me 23. So $23 for that situation. So those are the types of problems you're going to see on the test. Good luck.